All right, Giants, and welcome back. Go ahead and turn to 5.3 of your notes. Today we're going to talk about exponential graphs, and exponential functions. So the first thing for you, exponential graph, they aren't all going to look exactly the same, but some variation of this. Sorry, that's not the best drawing, but basically it goes and it gets bigger and bigger. Let me put that on a graph like that. Okay, sometimes instead of getting bigger, it's going to go the opposite way. You're going to get smaller. Okay, and the reason it's called an exponential is because our initial function deals with an exponent, and the x is in the exponent. Okay, so if we look at this first problem, if we're trying to plot it, notice I have the t-table over the left, a couple different things I'm going to plug in. So if I put in a -3, 2 to the -3, anytime we have a negative, that's the same. 2 to the -3 is the same as 1 over 2 to the third. Okay, so 2 to the third is 8, so that's 1 over 8, which is 0.125. Now, when it's 2 to the -2nd, it'd be like 1 over 4, which hopefully you guys know is 0.25. To the -1, that'd be 1 over 2, or 0.5. Now, when we raise it to the 0, anything raised to the 0 is just 1. 2 to the first, you know, is 2. 2 to the second is 4, and 2 to the third is 8. So at this point, we can plot these points. And just do your best. I know the fractions or the decimal ones are going to be tough. Just do your best. And it should look about like that. Now, we need to analyze this. The domain here, what are the possible x values? As you can see, this extends and keeps going up. This will keep going that way. So our domain would be all reals. Remember, we can symbolize that with this symbol, the R. And that, if you need to make a note, is all reals. And anytime we have an exponential, that is the domain. The domain for these is always all reals. Okay, now our range, as you can see, this kind of clips over. No matter what x is, in this case, it will always be a positive answer. Even as our x is negative, that just causes us to have a fractional exponent. So we know it will stay above 0. So y is greater than 0. Okay, and now our final thing, the horizontal asymptote, where does that occur? You can kind of see it here if you want. You can draw it in. It approaches 0. So we have a horizontal asymptote there at y equals 0. Now, we're going to scroll on. There's a lot of things that are going to be similar about the next one. There will also be some things that are different. Okay? One thing also I want to point out, this not as much, don't worry about when it's below 0, or below 1, I mean. But once we get it, we have a pattern here, and 1 times that by 2, we get to 2, times that by 2, we get to 4, times that by 4, we get to 8. So 1, 2, 4, 8. Keep in mind that pattern. Now we're going to go to the next one. Same approach, except this time it's 3 is what we got. Now, 3 to the -3rd would be, well, 3 to the third, let's do that one first. That's 27. So -3rd would be 1 over 27. Okay, and 3 to the second is 9. So to the -2nd is 1 over 9. To the first is just 3. So to the -1st is 1 over 3. And anything raised to the 0 power is going to be 1. So once again, it looks very similar at first, except now it's going to be steeper. It's going to increase quicker. And that makes sense because right here we have a bigger number. So it will exponentially increase at a higher rate. Now, hopefully you've noticed the domain is still going to be the same. It's still all reals. So I can just put that R symbol. And we know the range, once again, has to be greater than 0. And that is because there is an asymptote, a horizontal asymptote at y equals 0. All right. Now, on the last one, we had a pattern of 1, 2, 4, 8. This time, it's 1, 3, 9, 27. You'll notice, instead of, on the last one, 1 times 2 is 2, 2 times 2 is 4, 4 times 2 is 8. That was because this term right here was a 2. Now we have a 3 there, so instead 1 times 3 is 3, 3 times 3 is 9, 9 times 3 is 27. Okay, so now flip it over to the back, and on the back things change a little bit because now we are dealing with what happens when we have a shift. So you guys already know how shifts occur, transformations, and it's the same rules as before. Okay, so what I mean by that, if there's going to be a negative in the front of it, that's kind of cause our graph to flip. Okay, now this h is up in the exponent. That h is going to determine if it goes right or left. So unlike in the past when we've said if it was in the parentheses determines if it's left or right, now it's is it in the exponent. However, it's still the same in that if it's negative, that's right, and if it's positive, it's left. So it's kind of counterintuitive to what you'd think. Okay, now the k, whatever's tugged on to the end, if it's plugged on at the end or tacked on at the end, that's up and down. And just like in the past with up and down, if it's positive, that means up. If it's negative, that means down. Now b, this is the term, like on the front we had 2 and then we had 3. This kind of determines how quickly it gets higher, kind of like your scale. And you can just kind of say this gives us the pattern that we're going to use for how far above the line. All right, so if we look here at this first one, 2 to the x plus 3. So the first thing I want us to do is acknowledge, is it going to go up, down, left, right? Is it going to flip? And since it's plus 3 tacked on at the end, that's going to be up 3. Now, if we shift it up 3, that means instead of our horizontal asymptote being at 0 like on the first two, that's going to shift up 3 to y equals 3. If there's nothing tacked on there, then it's just going to be y equals 0. But in our case here, it's y equals 3 because we got a plus 3 tacked on. So if we look at example 2, that's negative 5, so that'll be a y equals negative 5 as your horizontal asymptote. Now the range, since y equals 3 is our asymptote, that means y has to be above 3. Okay, that is our range. Domain, still all real numbers. Now, when we're graphing this, first let's go ahead and draw our horizontal asymptote in. So at 3, think of it with respect to your asymptote when you graph. So, since this is a 2, that's kind of our scale factor, just like on the front side when we had 1, 2, 4, 8. We're going to follow that same pattern. So if it helps you, jot that down, 1, 2, 4, 8. That is how far above the asymptote. So it does not shift left or right, so we start on the y-axis, go up 1, then go over, and it's up 2 spots above the asymptote. Over, it's up 1, 2, 3, 4 spots. If we kept going, it'd be up 8. We run out of graph. And then it keeps going, and we know it approaches our asymptote. But we also know it's not going to cross that line because since anything, no matter what 2 is raised to, it will always be a positive number, and we have to add that to 3. So it will always be above 3. So now, That's our graph. Let's try the next one. This one shifts in two ways. It's going to go right 4 because of the x minus 4 in there. And it's going to go down 5. Now down 5 tells us this will be y equals -5. So I'm going to drop and draw that in. 1, 2, 3, 4. Okay, so that is my asymptote. Now, I know since it's still facing up, okay, since this is a positive number at the front, we know it's still going up, so y has to be greater than -5. It's still all reals. Now, it's 3 instead of a 2. So instead of 1, 2, 4, 8, we still always start with a 1. Then just multiply that by 3. So 1 times 3 will be 3. Multiply that by 3, we'll get 9. If we kept going, multiply that by 3, we get a 27. Now, we always start on the y-axis, except this time it's going to go right 4. So normally it starts 1 above on the y-axis. We got to go right 4, 1, 2, 3, 4, and put a dot right there. Now, that was 1 above, we go over, and now it's up 1, 2, 3 above. We go over, and now it's up 1, 2, 3, 4, 5, 6, 7, 8, 9 above. If I went over 1, it'd be up 27. That's going to be off our graph, so I'm going to draw this in. And that one doesn't look quite as good as on the front, but that's because it's getting bigger at a higher rate. So we're done. Okay, 2 more for us. This next one, 4 to the x plus 2. So it doesn't shift up or down. However, it does shift left 2. So if it doesn't shift up or down, that means it's still going to be y equals 0 as our horizontal asymptote, which means y will still be greater than 0. As always, the domain is all reals. Now we need to find our pattern. So we always start with 1 above. In this case, we have a 4, so times 4 gives us 4. Times 4 again gives us 16. I could keep going, but 1, 4, 16 is enough because that'll be off our graph. Now it shifts left 2. So instead of starting on the y-axis, we go left 2 and go up 1. Then move it to the right and up 4. If I went 1 more over, and it'd be 16 above the asymptote, that'll be off our graph. So we draw it in to the best of our ability. It's going to be very steep there. Head back towards our asymptote, and we are done. Okay, our final one we're going to graph. This last one crucial thing we got to notice right here is the negative. So that tells us it's going to flip. Now, the plus 2 here still is up 2. So it's going to flip, and it's going to be up 2. So if it's up 2, instead of y equals 0, up 2, so it would be y equals 2. Now, be careful, this one flips. So our domain is still all reals. However, instead of y being greater than this line, if it flips, that means y has to be less than the line at 2. Okay, you know it's going to flip upside down. So now we got to find our pattern. So instead of 1, then we multiply that 5, multiply that by 5, we get 25. However, this time it is flipped, so it's below. It's going to be below. So we start on the y-axis, it's 1 below. Then we go over, and it's 5 below. Then we'd go over, and it'd be 25 below, except that's off our graph. So it's going to go very steeply like that, and it comes towards our asymptote, and we are done. So go ahead. Remember, tomorrow is a catch-up day. Please take advantage. If you are behind on quizzes or tests, definitely get one of those done. Today there is a Desmos activity. Go into the folder for today, click on the notes. It'll tell you exactly how to do it. As long as you enter your name, once you're done, you don't have to submit it. It automatically sends it to me, and I'll have it. But please, if you have any questions, let me know, and I will see you guys later. Bye.